Hello everyone, welcome to Competition Safari. Today's topic will be time, speed and distance. This will be the first part of this topic, and in this video we'll be discussing some basic problems on time, speed and distance, wherein we will get a clear view of what is the basic of this whole topic, and we will do this by discussing some very basic questions. Then we will move on to the competition safari method, wherein we'll see our home based method, which will save us a lot of time, and it makes our solution very easy to solve. Then there will be some direct formula based questions, wherein you can put the values from the questions directly into formula to get your answer. So let's begin with our first topic. First question. So basically the most basic formula on time, speed and distance is distance is equal to speed into time. So most of the books, almost all the books discuss this formula, and all the questions are based on this formula essentially. This is the base of all the formulas. So you're seeing here that distance is equal to speed into time. Likewise, speed will be distance by time, and time should be distance by speed. Also, if you are given a speed in kilometer per hour, and you need to convert it to meter per second, what you will have to do is multiply that quantity with 5 by 18. So here we have 36 kilometers per hour, and we need to convert it into meter per second. So we'll do 36 into 5 by 18, which gives us 10 meters per second. And if you're given a value like 20 meter per second, and you need to convert it to kilometers per hour, you will have to divide that, multiply that quantity with 18 by 5. So in this case it will be 20 into 18 by 5 times 4, which gives you 72 kilometers per hour. So this is just a very basic overview of time, speed and distance. Next, let's discuss some questions on this topic. So you are given the length of a train, which is 100 meters, and the length of the platform is 200 meters. The time taken by the train to cross the platform is 20 seconds. We have to find the speed of the train. What happens here is you are given the length of the platform and the length of the train, which is 200 meters of the platform and for the train this train is 100 meters. So the total distance here will be what, let's say first, let's understand what the question is saying. It is asking the total time to cross the platform, which means the total distance this train is covering until the last bogie or the last portion of the train has already crossed the platform. So in such questions, the total distance will always be the length of the platform plus the length of the train. So this total distance is 300 meters here, and the total time taken to cross it is 20 seconds. So the speed of the train becomes 300 by 20, which gives you 15 meters per second. So this was just to explain what the crossing of train means, what it exactly means. So just remember, the total distance here will be the length of the platform and the length of the train. Next question. Okay, this topic of relative speed usually confuses us a lot, and to solve this confusion we just need to remember one thing, and I'll explain that with the help of a question. So you have train 1 traveling at a speed of 20 meter per second, and you have another train 2, traveling at a speed of 30 meter per second will take two destinations A and B. So train 1 is moving towards B and train 2 is moving towards point A. And the total distance between A and B is 600 meters. So in terms of relative speed, we have two conditions. In the first case, when the objects are moving when the objects are moving opposite to each other, the direction opposite to each other, which means if train 1 is moving towards B, then train 2 is moving towards A. So these two objects are moving in direction opposite to each other. So the relative speed in this case will be the addition of the speed s1 and s2. They are traveling with speed s1 and s2. And when these two objects, let's say if train 1 is moving towards B and train 2 also moves towards point B, the relative speed in this case will be s1 minus s2. Now sometimes you might get a negative value for this, but you need to ignore the negative sign and just take the modulus value of the quantity that you will get. So in this question we have cleared what the relative speed should be if we have to add it or we have to subtract it. Now it is asking that after how much time will both the train cross each other if they are moving in opposite directions and they start at the same time. So the total relative speed for this case should be 20 plus 30 because they are moving in opposite directions, which gives you 50 meters per second. The total distance they are covering is 600 meters. So the time taken for crossing each other is 600 by 50. So after 12 seconds, they will cross each other. Just remember one thing, that if the objects are moving in opposite direction, add the speed. If they are moving in the same direction, subtract the speed. Next question. Okay, we have a boy who goes from home to his tuition every day. On the first day, he went at the speed of 40 kilometers per hour and he reached to his tuition 10 minutes late. Next day, he increased his speed and he went with 50 kilometers per hour. This time, he reached his tuition 5 minutes early. We have to find the distance that the boy is covering every day. So, if you see the traditional method, you might, I'm not sure about this because I don't take the longer route. So if you take the traditional method, you might have to make two equations where you will assume that the distance is same and the speed is 40. The time taken, if he is not late, he should have reached by t minutes, but he is late by 10 minutes, so 10 more minutes. Another equation, d by 50, this time 5 minutes early, but we don't have to do this. Here we have a direct formula to find the distance, which is s2 into s1 upon s2 minus s1 into the total time. So here we have 40 into 50 upon 50 minus 40 into total time. Now the total time is 15 minutes, but all the quantities are given kilometers per hour. So we will convert this this quantity which is in minutes to hours. Now if we solve this, we will have 200 upon 10 into 1 by 4, 50. So the boy is traveling 5 kilometers every day to reach his tuition. Now just compare the traditional method, which would have taken you two equations and solve them, which will be again lengthy and very time taking. And then we have a direct based formula based question, which will give you a direct answer. Now this question especially, we have observed that it has occurred too many times in SSC exams, and so is the next question that we will be discussing. So we have here train 1, which is traveling from Delhi to Agra in 5 hours, and train 2 traveling on the same route from Agra to Delhi in 6 hours. Now we are not given the distance, we are not given the speed. What it is asking us that after how much time will they meet if they start at the same time. So we have Delhi and Agra, and then we have train 1 and train 2. So train 2 is moving from Agra to Delhi, so it's moving in this direction, and Delhi is moving, and train 1 is moving from Delhi towards Agra, so it will be in this direction. Now their total time is 5 hours and 6 hours. So if you take the Doctrine method, which will be again very lengthy because we'll have to make too many assumptions about the distance or the speed. But what we will do here is we'll take the speed as the LCM of the the time given to us. It will make our solution very easy. So let's say that our total distance is the LCM of the time given here. So the LCM is 30. Our distance becomes 30 kilometers. And the speed of train 1, the time taken by train 1 is 5 hours. So the speed becomes 30 by 5, which is 6 kilometers per hour. And for train 2, the time taken is 6 hours. So the speed becomes 30 by 6, which is 5 kilometers per hour. Now the relative speed should become S1 plus S2 because they are moving in direction opposite to each other. So it will be 6 plus 5, which gives you 11 kilometers per hour. Now we have the relative speed. We have assumed the distance to be 30 kilometers. Now we'll find that after how much time will they meet. So you have distance upon relative speed, which gives you the time as 30 upon 11, which will be 2, and 8 by 11 hours. So here we just see that we solved the question by just taking a very, very simple assumption, and we got the answer as 2 hours and 8 by 11 hours. If you might be thinking, what if our assumption is wrong? So we'll take another example where we have changed the values, where we have assumed that, okay, let's make the distance as 1000 kilometers. Okay, we'll do that. So we'll take the distance as 1000 kilometers. Now Delhi, Agra, distance becomes 1000 kilometers. Train 1, train 2, traveling in opposite directions. Time taken is 5 hours, 6 hours. So your speed 1 becomes, for train 1, speed becomes 1000 by 5 hours, which gives you 200 kilometers per hour. For train 2, speed 2 becomes 1000 by 6, which gives you 166.66 kilometers per hour. Now the total relative speed becomes 166.66 plus 200, which gives you 366.66. So we have the relative speed, we have the total distance. Let's divide to get our answer. Distance by relative speed is 1000 upon 366.66, which should become 2.72 something. Now, previously we had the value of 2 hour and 8 by 11, 2 into 8 by 11 hours, which surprisingly also becomes 2.72. So we have the same answer for both our assumptions, which means that it is not dependent upon the solution is not dependent upon the distance. We can simply take the LCM of the two quantities because it would have made our calculation very easy. You can get rid of all these complexities of 1.166.66 and then dividing it with 1000, which gives you some answer in points. And comparatively, I think this would be very easy to do this, taking the LCM and then just dividing it by the two values. It gives you 2.72. So we have just witnessed that by taking the doctrine method, things become very, very, very complicated. And if you take the competition safari method, you will observe that you not only save a lot of pain, but you also saved a lot of time when solving such questions. And one more thing, this question also has appeared in SSC a lot of times. So just take a shorter approach and practice it. Next question. Okay, this one is also based on relative speed. So we have train 1 traveling at a speed of 60 kilometers per hour and train 2 traveling at 50 kilometers per hour. Let's say Mumbai, Pune, and the total distance the train is covering is 600 kilometers. Now train 1, which is traveling at a speed of 60 kilometers per hour, and train 2 traveling at a speed of 80 kilometers per hour. So train 1, which is traveling from Mumbai to Pune, okay, so we have train 1 traveling at a speed of 60, train 2 traveling at a speed of 80 kilometers per hour. Forgive me, it should be 80. It is 80 kilometers per hour. So yeah, we have 80 kilometers per hour and the total distance they are covering is 600 kilometers. So let's say Mumbai, Pune, and the distance between them is 600 kilometers. Now train 1, which is starting at 6 a.m. is traveling at a speed of 60 kilometers per hour. Train 2, also traveling from Mumbai to Pune, is traveling at a speed of 80 kilometers per hour and it is departing at 8 a.m. We are asked after how much distance will they cross each other. So let's see what we have here. We have a timeline, Mumbai, Pune, and the starting time is 6 a.m. So at 6 a.m. train 1 is at Mumbai after 2 hours, which will be 8 a.m. It will be 2 hours ahead. So in 2 hours it would have covered 120 kilometers, and at 8 a.m. Mumbai, Pune, Train 2 is here starting at 80 kilometers per hour. So in this case, the total relative speed should be 80 minus 60, which gives you 20 kilometers per hour. And the total distance it has covered, when train 1 is 120 kilometers ahead. So train 1 is 120 kilometers ahead and the relative speed is 20. So 6 hours, which means train 2 will take 6 hours to cross train 1. But we are asked the distance at which they will cross. So in 6 hours, train 1 should be 480 kilometers from Mumbai. It will be somewhere here at 480 kilometers. So yeah, we have our answer. The distance which train 2 will cover is 480 kilometers before it crosses train 1. Next question. Okay, we have train 1 traveling at a speed of 36 kilometers per hour and train 2 traveling at a speed of 42 kilometers per hour. They are traveling direction opposite to each other. Train 1, train 2, and they are traveling direction opposite to each other. So we have point A, point B. Speed 1 is 36, speed 2 is 42 kilometers per hour. Now it is saying that when the two trains crossed each other, at some point Y, it was found that the train 2 had already covered 48 kilometers more than train 1. So we need to find the total distance between the two stations, between A and B. Now again, if you see the doctrine method for this question, it will be very lengthy to find the solution. But we won't do that. What we'll see here is we will compare the two speeds. So train 1 when traveling at 36 kilometers per hour and train 2 traveling at 42 kilometers per hour. So in 1 hour, train 2 is traveling 6 kilometers more than train 1. And because the difference is 6 kilometers per hour, so it is covering 6 kilometers more than train 1. So to cover 48 kilometers, how much time it would have taken? 48 kilometers. It would have taken 8 hours. So it took them 8 hours to meet each other, to reach a point at point Y. So the total relative speed should become S1 plus S2 because they are traveling in opposite direction, which means 36 plus 42, which gives you 78 kilometers per hour. And you know the total time taken by them, the total time which they traveled is 8 hours. Time is 8 hours, so distance becomes 78 into 8, which is 4, and this becomes 7 times 7, 56, 62. So they covered 62 kilometers. Some was covered by train 1 and some was covered by train 2. Total distance is 624 kilometers between point A and point B. Next question. Okay, the speed of a train is 45 kilometers per hour and the length of the train is 30 meters. It took 30 seconds to cross the platform for the train. Find the length of the platform. Okay, let's see the data that is given here. We are given the speed, which is 45 kilometers per hour, and the length of the train, which is 130 meter. So let's see the doctrine method. Let's see the doctrine method, which all the books and all the other video channels follows. So they take some assumptions where distance, which is length of train plus length of platform upon speed. So since the length is given in meters, we'll convert 45 kilometers in meter per second, which will be 12.5 meter per second. So we have the total distance and the total speed is 12.5. Now the total time taken is 30. But we will not do this. We won't take this lengthy process. We will see, okay, it is taking 30 seconds to cross the platform. So in 30 seconds, traveling at a speed of 12.5, the train would have covered 12.5 into 30, which gives us 375 meters. So the total distance that train covered is the length of the train and the length of the platform, correct? Which gives us 375. Now if we subtract the length of the train, we will have the length of the platform, which is 245 meters. So we didn't take the lengthy process. However, we just applied a simple logic, which usually is known as common sense, and we find our answer with very ease. Let's take another question. Now this one is pretty tricky and I don't know if you are prepared to solve this one, but since it is very intriguing, you must see the solution. So we have an aeroplane here which was supposed to depart at 6 a.m. but due to bad weather it was delayed by 30 minutes. Now the total distance it had to cover was 1500 kilometers, but it was delayed by 30 minutes. So they increased the speed. The speed was increased by 1/3 to cover this delay. To reduce the delay to 0 minutes, the speed was increased by 1/3. We need to find the initial speed and the final speed of the plane. So let's give you some time to solve this question from doctrine method, or just try to solve it. I'll give you some time, or you can pause the video. Okay, I assume that you have tried and you might have taken a long route. What you are seeing here is a chart with some values, and you can see some percent increase and percent decrease. So here we have an increase of speed by 1/3, which means 1/3 is also equal to 33.33. So as an increase in 33.33% will decrease the relative quantity by 25%. So speed was increased by 33%. So the time was decreased by 25%. How this happens is, if you see the detailed video for the percentage basics, where we have explained how the two quantities are related. So if we increase a quantity by 33%, the related quantity will decrease by 25% to maintain the same. So here we have decreased the time, which was 30 minutes, and 30 minutes is equating to 25%. And we have ramped up the speed. We have increased the speed by 33.33%. So if 25% is 30 minutes, how much should be 100%? 100% should be 4 times of 30 minutes, which is 120 minutes, which is also known as 2 hours. So we have total distance 1500 kilometers and total time is 2 hours, which is 750 kilometer per hour. Now we have our initial speed as 750 kilometers per hour. Now that we have increased the time by 33% or 1/3, the final speed should be 1/3 of which is 1000 kilometers per hour. Just see how shortly with we find the solution, and without taking any assumptions or equating some variables, just by seeing these values. So if you have seen our time and work part 1, where we have discussed how 1/3 becomes 33.33%, and it helps us in finding the values, in finding the solution. So just try to watch our video on percentage basic, and you will learn how the two values are related. Moving to our last question of a train passes two persons who are walking opposite to the direction of the train at the speed of 5 meter per second and 10 meter per second. And they do it in 6 seconds and 5 seconds respectively. Find the length of the train and the speed of the train. So what's given here is we have two persons, person 1 and person 2, who are walking opposite to the train, and they have a speed of 5 meter per second and 10 meter per second. The speed of the train should be st, which is not given, and we have to find it. So let's collect all the data that is given here. The speed for the train is st, speed of person 1, speed of person 2. It remains as it is. Let's say x. Speed of person 1 is 5 meter per second. Speed of person 2 is 10 meter per second. Now the time we have is t1 is 6 seconds and t2 is 5 seconds. So only one thing is fixed here, the distance. So here the total distance will be the total length of the train, because that's what we are given the reference for. They are crossing the train in this much time. So our distance remains same. Distance should be d of train. It's better to represent length of the train. So only one thing is fixed, and we are given two different times and two different speed. So if we have to find the relative speed with respect to person 1, which should be speed of train, which is x, and the speed of person 1, which is 5. So this should become the total, the relative speed for person 1, and for person 2 it should be x plus 10. Now we have just one thing which is fixed here, which is distance. We know that distance is equal to speed into time. So if we equate these two equations, we'll have our distance, which should be, we'll have our value of x, not distance. So since distance is same, we can write x plus 5 into total travel time is 6, which is equal to x plus 10 into total travel time, which is 5. So if we equate this, we'll have 6x plus 30 equals 5x plus 50. If we solve for x, we'll have 20 meter per second. So here we have found our value for the speed of train, which is 20 meter per second. Now we have to find the total distance traveled which will be the length of the train. So if we put the value of x, we'll have 20 plus 5 into 6 gives you 30, gives you 25 times 6, which is 150 meters. So we have the length of the train here and the speed of the train by using the relative speed concept. There are certain direct formulas for this, but it's a two-line solution if you see it practically, because I'm writing all this solution just to explain you. If you were to equate it, you can do it you can calculate it in your mind and get the solution. So that's all for this video. That's all for today's video. In the next part of time, speed and distance, we'll discuss some medium level questions and some doubts that which will be posted from your side. Also, if you liked today's video, if you found it helpful, please subscribe and like our channel and our videos to get new updates about our channel and help us grow. Thank you so much. See you until next video.